Introduction to vectors and scalars. This will be the start of a new series on physics. I'm well aware that I have several videos here which I haven't done in a while, or rather just say I haven't added any new videos to them, but I will be adding many videos to those shortly. I just haven't gotten around to doing that quite yet. But this video series will be pretty long. I am guessing several dozen videos, if not more, on this topic. It'll be like it'll be relatively advanced physics, nothing like super sophisticated, but it will be a pretty more advanced physics, I should say. We're talking about things like velocity, the basics. Then we're gonna get into more stuff like particle physics, astrophysics, a little bit of quantum mechanics, that sort of thing. Some little some mathematical physics, so a little more rigorous stuff. Now that I'm more read up on the subjects. So okay, so let's just get right into it. This will be a video on vectors and scalars introduction. So what exactly is a vector and a scalar? Well, those of you who have physics, is pretty basic stuff. This is physics 101. But nevertheless, this video will take an interesting look at it because we'll tie in some linear algebra into that. Well, basically a vector is something that has magnitude and direction, meaning like it will in order to properly define it, such as velocity, you have to be going in a certain direction, but then how fast you're going. Like meters will be the magnitude and speed. Well, actually, yeah, meters per second. You need two parts to describe the vector. You have magnitude and direction. It will be meters per second in such and such direction. And of course, you have other quantities such as currents. Voltage divided by resistance. Well, actually, I should say yeah, amperes per meter. Actually, sorry, magnetic field. That was I incorrectly stated that. Basically, so a vector is simply just magnitude and direction. A scalar is something that only needs one characteristic to define, such as temperature. Temperature would be a scalar quantity because it's not really in any given direction. It's not necessary to define it. But velocity, magnetic field, and other topics we'll be talking about will be vector quantities. So essentially, vectors are typically represented by either a with the arrow over it, sometimes with a half arrow, but I personally prefer the arrow. Makes a lot of sense, and that's also used quite frequently. Or just simply a bold-faced letter, which I just simply put for A. So let's just look right into it. So here I have a vector A, and notice that this vector is pointing to the right. Well, this is positive in the positive x direction, so it would make sense that this number is positive. And following from that, we have this negative A, which is a vector pointing in the opposite direction and going left. Now notice this arrow has a direction and also has a magnitude because it has a certain length. Like you can pretty much say that both of these vectors are the same length, but the same magnitude, but opposite directions. Actually, these two vectors will cancel each other out, and we'll talk about that when we get into net force and things like that. So let's just go into the linear algebra aspect of it all. So let's suppose we have a vector which is represented by a matrix with 2 and 3 as the entries. Now, those of you who haven't had linear algebra, this is a pretty simple concept to understand. Basically, you have these two numbers, and it basically defines a certain point in space. In this particular case, it's an R2 or real space 2. Typical stuff, like slope-intercept form, that's all done in R2. You have an X and a Y axis, two parts to identify the graph, if you want to word it that way. So we have 2 and 3, which I've drawn down here. You basically just go 2 and then up 3, typical, graphing of, any coordinates. But now here we have 2a, which basically is a scalar multiplication, which is where you take the vector and you multiply it. You basically increase the magnitude, but you keep the direction the same. And so here, as you've seen, I've increased the magnitude by I doubled it basically. As you can see here, it's 4 and 6. You just simply multiply every entry in the matrix by 2 because that's what this 2 over here means. So again, vectors are simply just something that has magnitude and direction, such as velocity. Pretty basic basic physics however you want to word that concept to understand. And then scalars are something like speed and temperature. You only need one number to one characteristic to define them properly, and you can actually take vectors and multiply them by scalars to change their magnitude. Now, if you multiply it by a negative, such as if I put negative 2a, then both of these entries will be negative, and in this vector right here would actually be pointing in the opposite direction, which we'll also be getting to that more in the upcoming video. So this is an introduction to vectors and scalars. We'll be talking more about them in the upcoming videos. So I hope you guys enjoyed. See you guys in the next video.